Good evening, Professor. Welcome to our small presentation for our capstone project. Prash, can you next slide, please? So, in this project, we have developed a mobile application that is capable of detecting and recognizing faces, and this small application is called Face Shot. And Face Shot is really fast, it's accurate, and quite dependable. But before that, let's get on to the problem. So, on an average, roughly 4 to 5 minutes are wasted per class to complete an attendance. And even in this procedure, there are a lot of errors like proxies or missing students that haven't been reported. And these slight issues are taken care of by us. Because if we do the math, roughly 34,000 hours are wasted daily in the United States alone. Just think about the number worldwide. Then, assuming that professors are paid hourly, we can easily convert this time into money. And that's quite true as well, right? And the amount comes to a staggering $1.4 million that is spent daily on taking the attendance alone. That's a lot of time and money wasted. And for that, we came up with a rather elegant solution. We decided to use face recognition and to register attendance for students. So face recognition takes a really small amount of time to actually capture the image, and our server quickly detects the faces and marks the attendance for them in the background. So the entire process that used to take around 4 to 5 minutes have now been shortened to a really small span of 2 to 3 seconds. And for this technology, we would only require a cell phone for the teacher, which for them for marking the attendance, and which nowadays almost everyone carries. And this small app is not only really light, but can be also readily shared and can also be integrated with other solutions as well. And just as a solution, we are planning to implement it as on a subscription basis, so that schools or other places could actually subscribe to our payment monthly month to month payment modules and use them. And if you look at the market scenario, there are over 132,000 schools with 300 million students in the USA alone. And this comes around to 300 million schools around the world. And the education industry is a big industry, making over $1 trillion per year in the market. Now, moving on, Ram will explain the flow of our application.
Thank you, Jaren. So this is our flow, a complete flow. This teacher will click a picture of the class using our application, and this image is sent to our backend server. And the server will receive this image and pre-process it, and feeds into the face detection model. The model will detect the faces and recognizes the students, and at the end the noises are filtered and the final predictions are sent back to the front end. So once these results are received in the application, the database gets updated and that attendance is visible for the teacher. Next slide, please. So this is our tech stack, and we have designed our front end using the Flutter framework, and which was developed in Dart programming language. The web app was also an extension of the Flutter framework, and the backend server is developed using Flask, which is ultimately developed using Python. And this Flask, we have used Docker and GCP to host the Flask application in server. And for the computer vision part, we have used the TensorFlow framework. And for image operations, we have used OpenCV. And finally, all the code was pushed to GitHub to deploy in GCP. And the database we have used is Firebase to store the images and the attendance details. So that's it for the tech stack. Now I'll hand over to Praharsh to show a small demo.
Thank you, Jarin and Ram. Unfortunately, we are not able to meet in person because of COVID, and so I'll try to demo the product over webcam. And this is not the ideal scenario because we are currently dealing with lighting issues and also screen glare issues. But even then, let's see how the model performs. I'll be using first the mobile app, and I'll firing it up. I'll try to fire it up, share my screen, and see how it works over our faces. So let me just try and start sharing. There is my mobile screen. And coming on to the app, I'll give you a brief demo of how the app is. So currently I'm signed into the teachers portal. The app asks for the user ID and password in order to log different teachers in. So I can see that I am currently in a class for like 4 hours. I can actually modify my timetable over here. I can add as many classes as I want, and I can reduce the classes as I want. So whenever I want to take an attendance, I'll just click on the attendance list tile over here, which will then fire up my camera. And let me just point my camera over to the screen and try and look at the camera. Okay, so what the app is doing right now is trying to update the model into, or update a photo in the backend to be able to process by the model, and it will also create a copy to Firebase database in order for us to be able to see the photos later. And as we can see, the model has successfully detected me, myself, and Jaren. Now, over several attempts, RAM can also be detected. And for example, since right now we don't have the perfect lighting condition, model wasn't very certain that it is in fact us. So what I can try and do is click on the change attendance button over here. So what it does is it earlier marked us absent because of the low accuracy score, and after tapping this button, it will actually retrain the model on the updated name, but also mark that particular student present. So let me also mark Janin as present, um, marking him as present, change attendance. Okay, so let me just go ahead and try and take another snapshot and see what we come up with. So again, pointing the camera, pointing my face, and the same process happens again. It tries and uploads the photo to the cloud. Model tries and identifies what sort of faces there are, and then it gives us the result in form of for list view. So just waiting for the results. So the model just came up with the results, and it has marked me. Actually, it's marked everyone present, so everyone was able to get detected properly. I'll also now take you through the process of training a new student. So let's say I have a photo of Mike Tyson over here. So what I'll do is try and snap a photo of Mike Tyson. Let me quickly reposition the screen. So it's trying to do the same thing. It'll try and run the model over on Mike Tyson's photo. And since Mike Tyson's is not added to the database, I can click over here, and it is asking me to add the student's email ID. So this will be used as a unique identifier in the database. So I'll just say Mike at mike.com.
Microsoft.
Even better, let's say and Mike, and here I'll just write his name, Mike. And now the model is retraining and updating its embedding, so that the next time I take any photo, they should be able to, or the model should be able to pick up Mike off of the recording.
Go for it.
Okay, so the model was just trained on Mike Tyson. I'll try and take a photo. Um, Let me go ahead and take photo. So it's now loading. Ideally, it should be able to detect Mike's photo, since even though we have trained him on a single photo. Now obviously, as longer the model works, and as more times we train the model on a single face, it will be more accurate. So the model has returned with the results, and we can see there are about six correct predictions of Mike, and six because um, the search results over here have a lot of Mike Tyson's photos, so it also picked up the images that are small and that were in the background. And now let me take you through the web app. The web app can be visited by going through this link. It's the exactly same app. I can again take the attendance using my webcam like so, and it'll do the same thing. I can also try and upload my own image. So if I go click here, I should be able to access the gallery and upload my own photo. So I won't be doing that since it's repetitive. I also will now take you through the database. So we are using Firebase as the backend. And over here in the authentication area, we have one teacher logged in. So this account is then used to log in using as a teacher. Now the database that we are using is the Firestore database, and um, this is the set of collections which we are using. Students is all the students that we registered. So the latest one was Mike Tyson. We also trained the model in few of the other images or few of the other students which are also logged on over here. Each and every time we add a new student through the app, another document is made over here. Teachers are the all the different teachers account. Timetables are the time slots for each and every day, and so teachers should be able to edit their own time slots from here. We have put our endpoints over here in the variables collection, so whenever and if our endpoint changes, we can just update this variable. Going into the attendance, this is where attendance for different slots take place. So let me go into this. So this is the latest attendance. There were prediction for Mike, Jarin, myself, and Ram, and there's also a new student who was detected with an accuracy 0.09, which was also logged in here. And for each and every result, we have the link to be able to access their image. Um, the link itself is stored in Firebase storage. So if you go into storage, we go into attendances and the teacher's UID, we should be able to see all the images of the attendances made. Now few of the images are old since we have been trying and different models or sorry different images in order to train this model, and so over time this bucket will be able to um, hold all the images which were taken by the app. So that was a short demo for the app. Thanks for joining.